I would like to give a gentle reminder to all the participants to kindly maintain the decorum of the session. For queries, please use the public chat box or raise your hand if you wish to speak. We all provide mic access at the right time. With that, let us begin the second session of Model Mind and continue our journey of innovation and discovery. Now,
Okay.
I'd like to Mr. Gaurang Kumar Baishya sir
Okay. Thank
to
you.
speak.
Yeah. Thanks for the introduction. Yeah. Sorry. Sorry, I'm a bit rushing. So because we are already a bit, and I really do not want to cross 7 p.m. because everybody has work to do, right? Okay, let me quickly finish. So we'll do a little bit of a hands-on today. We'll start off at uh, um. Wait, how do I share the? Where is my screen? Oh, sorry. Yeah, for some reason, I'm not being able to share the screen. Just give me a minute. Um, okay, okay, here it is. Right. So can you guys just confirm if you can share, see my screen? Like, are the presentation slides visible?
Yes, sir, the slides are visible and you are audible also. So we can continue with the session.
Okay, okay, great. Thanks. Right. So, okay. So the first session we talked about uh, the very basics of ML, and I explained to you what are different kinds of. First of all, I explained to you what was going on before ML, the traditional methods. Then I explained to you why is it required. Then I gave you a little bit of an exposure to the different kinds of ML available, not in terms of algorithms, but rather in terms of um, types of, okay, based on human intervention. And having said that, I think I also talked a little bit about overfitting, underfitting. Did not touch base on, did not talk much about regularization, but we will see regularization soon. No worries with that. Don't worry about it. Um, then we check, what did we check? Yeah, we checked the underfitting, overfitting, and we talked about some of the issues uh, with overfitting, underfitting, some of the issues with data, the poor quality of data, where data distribution is representative of the true distribution and all those stuff. So we checked all of this stuff. Now in this slide, I would like to take you through a project. Okay? I would like to take you through a very simple project. And I would like to show you that this is what people do when they say I'm doing ML. Okay. But the only difference between what most people do in a research setting or in an industry is going to be an overcomplication of what we will see today or tonight, right now. Might be a little bit more complicated than what people do, but more or less the entire idea is the same. So, okay, so far so good. Do you have any questions? Let me know if you have any questions. Okay, okay. No questions? Feel free to just ask any questions in the chat or, you know, unmute yourself or uh, raise your hand, whatever. All right. Um, okay. So, okay, let's start. Right. Uh, one second. Okay. So, in this particular small project, we will do the hands-on. No worries with that. Just like the first we have like 1.5 hours because I would do not want to cross 7. So maybe half an hour we see the slides, and then the 1 hour I'll show you how everything is carried out in Python. All right. Right. So the first thing is when we do this project, we will be working with some sort of a data. But which data we'll be working with, I will be taking on this particular data. It's called California housing price prediction. Sorry, prediction is not a part of that. It's like the California housing price. So this is going to be a regression problem, which is going to be a supervised ML problem. And yeah, I mean, again, today I'm keeping it very simple because most of you are not aware of what is ML and you're not aware of the true intricacies. So I'm just keeping it simple. Although might look simple, you can always go in depth. Okay. So my data is California housing price, and we will see how this data looks like. But yeah, so this is a bigger picture. We'll look at the data. We will visualize data first, and after we have the data, we will visualize the data, and we'll see what kind of informations can we find out from the data in terms of visualization. Then we prepare data, we select and train a model, then we fine tune your model. So when I say fine tune, that's when the hyperparameters come to the picture. And then we launch, monitor, and maintain. So this is the last part of anything you do. I mean, you're so if you work in an industry, you're going to launch a product. You are doing a project, you're going to launch it. You'll launch it for the users to use it, or it could be to the public, whoever the group of people will be involved in this. Okay, so this is like the last part. Right. So let's start. Yeah. Okay, are there any questions? Um, okay, there are no questions. Great. Okay, so what's the primary objective of the data? So, okay, of course, we'll do the hands-on. I just want to lay down the entire project in terms of the written slides, so that we have the entire idea at the back of our mind. Okay? So we have the entire idea at the back of our mind, and when we do this Python coding, or rather, I'll show you how this code works. Then you will get the idea of what we are trying to do. Okay, this is the main reason why I have the slides for the project, and there is no other reason for the slides. So this is entirely a project, and this is just a description of. Okay, so we build a model that predicts the median housing price in the California districts using the 1990 census data. So this data that we have, uh, sorry. Okay. So this data that we have is a old data. It's a pretty famous data, and the model that we build on this is going to be a model that predicts the median housing price across the districts. Okay, that's the primary objective. Don't ask me questions on what's going it to be. We will see. We'll see in the end. But just for the right now, just imagine that this is a prediction game. We're trying to predict something, and it's going to be a supervised machine learning problem. And in the supervised sector, we will be talking about whatever we will be talking about is a regression problem. All right. So what's the business context? The model's output will be a crucial signal for a downstream investment analysis system. The accuracy of this prediction directly impacts business revenue. Okay, so um, this is a very dummy example, most probably a very stupid example, but you can see the region. You can see what's going on. Any machine learning model that we launch will have objectives. The objective could be research. Most often, the objective is business. Uh, there can be different other objectives as well. But if we consider this objective as a business, then you can see how this business works. I mean, I won't explain how this business works, but at least you can see uh, how that particular group of people for which this model is built is benefited in their business by this model. You can see that this could be investment analysis system. An investment game could be a good business, but it's a very dummy example, stupid one. Yeah. Data pipeline. This project involves creating a full pipeline. Okay, sequence of data, blah, blah, blah. All this I explained. Let's go to the next slide. Framing the problem. So this is important. Uh, this is important. How do you frame the problem? Okay, we haven't seen the data yet. Don't worry. We'll see it in the next slide. But I just want to give I just want to give you a outlook on how the problem looks like in terms of ML. So as I've told you, this is a learning. What's the learning type? The learning type is supervised. That means we have the levels of a few, if not few, some of the data. Don't worry about how the data looks like. What are the labels? We will see that next. But just for a time being, know that when I say supervised learning problem, that means we have the data set and a huge portion of the data set labels are known. Okay, the target labels are known. And the target labels are nothing but the median housing price. All right. Yeah, so it's a supervised learning problem. And what's the task type? So this is the learning type. Okay. What are the different learning types? There are supervised, there are semi-supervised, there are unsupervised, there are all those things we discussed. So the learning type is supervised. That means we have the labels and we will use the labels as a teacher to guide our inference. Okay. What's the task type? The task type is a regression task. So if you remember, there were two different task types. One was classification. I will not go back to my previous slides. That will waste a couple of minutes. But I'll just remind you. There are two different types of tasks. One is classification, and the other is regression. So when do we use classification? We use classification for classifying. Okay. I mean, spam versus non-spam, or rich versus poor, or just classifying tall versus short. Okay. Again, classifications can be of different types. We'll see classification in the next slide. In the next lecture. So today we will be talking about a little bit about regression. So I will tackle both regression and classification. Okay. So this is a regression task because, okay, so what's a regression task? Regression task is the same prediction game, but here something that is continuous. When I say classification, it's discrete. It's like a 0 or a 1. Okay, it's discrete. Spam is a 0, or spam can be considered a 1. Non-spam can be considered a 0. Okay, it's discrete. Continuous means it can take any values, in a continuous range, in any real numbers, say 5.4. That's how the median housing price could be, right? $5.4 million, for example. It's a continuous number. Or maybe $2 million or $100,000. It's a continuous number. It doesn't have a. Okay. Now, this is a multivariate regression thing. The reason this is multivariate is because we'll see that. We'll see that. No worries. Just keep in your mind that this is a multivariate regression. What's the learning method? The learning method is batch learning. Why is it batch learning? Because so there were two different types of learning, if you remember. One was batch and the other was online. So online learning is learning on the fly. You have data coming to you with time and you learn on the fly. Okay? This is not online, so it's batch. The reason it's not online is because there's no data coming on the fly. You have a fixed data. You train a model on that. You predict on. That's it. That's why it's a batch learning. Okay. So far, so good. If you have any questions, let me know. I'll wait for a minute or maybe 30 seconds. No questions? Are you guys following me? Are you guys following me? Okay. Okay, so will we deploy this project by today? Yeah, of course we can try that. No worries. Okay. Okay. Yeah. Will it share with us? Yeah, yeah, sure, definitely. I'll share everything with you. No worries. I will share everything. Just after this session ends, I will share the code. I'll share the yeah, I'll share the code right now. No worries. Will do that. Okay, no questions. Okay, great. Right. So yeah, this is a pretty simple problem. Yeah, I do not want to make things complicated. So otherwise you wouldn't understand everything. Uh, Always remember the goal is to learn the basics. Keep your basics very strong, then you will be able to understand very difficult things. So don't worry. All right. Okay. So okay. All right. So okay, we'll come to this. Let's have a look at the data. This is not the data exactly. This is like a summary statistics. Um, okay. So let's see something. Let's see a few things. I will explain it to you. How do I zoom in? Okay, I need to zoom in. All right. Uh, okay, don't look at these things right now. Forget about this. And just look at the columns for now. Okay, these are your columns. All right. So the data has a couple of things. One of the thing is, so basically the rows are nothing but some sort of a uh, house that is located in the state of California in the United States. So if you remember the United States map, California is to uh, the west of the country, and it's facing the sea, okay, the ocean. I don't know which ocean. I think it's the that Pacific also, or maybe if not the Pacific, it's like Atlantic. I don't know. It's towards the that sea. It's on the coast. Okay. Uh, it's on the coast, and you will have some sort of a couple of 100,000 houses. And for each house, you have these information. So you have the longitude of where that particular house is located. You have the latitude of where that particular house is located. You have the median age of the house. Okay, the median age is housing median age. So I'm not sure, pretty sure what is the meaning of housing median age, but I'm guessing that it's like the age of the house, the time of um, at the time when this informations were taken. Yeah, so how old is that house at the time when the information was taken? Okay. And next is total rooms, how many rooms there are in that particular house. So don't worry, these columns will be houses in the actual data set. This is just a summary statistics, so I will come to that. Then you will have the total number of bedrooms, you will have the population. Uh, okay, right. Population is in how many people reside in that house, I guess. Not sure. Could be. Yes. The households. Okay, population represents, I guess, the population of the place where the house is, or that small region. That could be number. I did not have a look at it. I just do know that these are some of the informations we have. I did not pay attention to individual attentions closely. Then we have the households. Maybe it represents the number of households in that family. Then we have the median income of the house of that region. And then we have the median house value. That is like the value of the house. This represents like $20,000. Oh, sorry, this is the count. Okay, so if this were the number, then for that particular house, this would have represent $20,000 or something. Okay, so what's the summary statistics? The summary statistics is that um, what is the mean of the longitude? If you remember what's a mean, mean is like the average. So mean of minus 119, this means that the mean of the longitude across all the different houses that this data set have is minus 100, something like that. Then we have population. For example, we have different features. The mean of total rooms could be. So, okay. Seems like it's not a, yeah, okay. Yeah, I think this information is for, right. Yeah, I think this is across a small region, a couple of houses across a small region. That's why the mean of the total rooms is so high. Yeah, but yeah, I know where is that, but I think this represents for a small region. Yeah, I think this is for a small region. I'll show it to you what that means. Yeah, so this is the mean. Similarly, the standard deviation, this is the standard deviation across different, this is the minimum value. So when I say the minimum, that means 2 is the minimum. That means across all the houses in that particular region, the total number of rooms, the minimum total number of rooms is 2. Okay. Uh, Max is this. I think it's some quite something interesting. We'll see that. Okay. Why is the, I think these numbers are not normalized. Uh, okay. I took a printout of the entire data. I mean, I have to check. But yeah, we have these informations. Don't worry about worry about the numbers here. They're pretty, and be, let's be a little chill with it. They're pretty informative. Just have to look at what each of these features mean. Okay, this is the summary statistics. And yeah, so in any regression problem, if you remember, I told you that, well, what was the machine learning problem? If you remember the definition, we have experience, we have a task, and then we have something called a performance, if you remember. How do you measure the performance? That is the, sorry, okay, 1 second. Yeah. So how do you measure the performance? So if you remember, there was this thing called performance. So when I say the word performance, that means there needs to be some sort of a metric based on which you find the performance. Okay. Uh, when I say the metric based on which I look at the performance is root mean squared error. That means we are trying to find the average error. Okay. So there are M houses, and I want to find the average error across these M houses. Okay, why does this measure error? Okay, this is my function that I am going to train. I'm trying to find this function h. Don't worry about how we find this h. This h is something we will find. Y is the true number. Y is the true label. Okay, so the median is 50 and the function says 45. Then what is the error? The error is nothing but 45 minus 50. And I am taking the average of these errors, squared errors. There is the region we are squaring it. Don't worry much about it. If you are too curious about why we're squaring it, you should also be curious about the fact that we are taking a square root. So in a way, uh, we are nullifying the effect of some way. We are nullifying the effect of the square. Um, and yeah, we are taking the sum of these errors and then we are finding the average. So in a way, the metric that I'm choosing as my performance metric is what is the average error in my estimation, in my estimate. Okay, this is my estimate, this is my error, and this is some sort of an average. So it's kind of asking, what is the average error am I making in my estimate? That's my metric. If my average error is too much, that means I'm not happy with my model. If my average error is too less, I am still not happy with my model. Okay, so we will be happy. Yeah, we might not be happy with the model even the average error is too less because we might be overfitting it, but we will talk about it later. So so this is called root mean squared. Root for this root, mean, M stands for mean for this 1 by M thing. Square, square is because of this 2. Error is this one. So it's called root mean squared error. Okay. So this is my metric, root mean squared error. Right. So this is my metric. If my root mean squared error is too high, that means I'm not happy. It's too low, I'm still not happy. Um, but I need to find the good value of RMSE. Okay. So there is one more metric that we could use. It's called mean absolute error. Instead of squaring it and taking the average, then taking the square root, we could do this. What is the something like asking, um, sorry, what did I do? It's something like asking, what is my mean absolute error? Okay. All right. What is my mean absolute error? Um, this is my error. This is my absolute. That means if it's a negative number, I am just making it positive, and this 1 by M stands for the mean. Okay, this is also a metric. But there are some regions we won't use this metric because sensitive to outliers. Don't ask me why it's sensitive to outliers. This is something you should know. I could explain why it's sensitive to outliers, but I will leave it to you as a homework to figure it out why it's sensitive to outliers. I think I talked about what's an outlier. Okay. All right. So this is my performance metric. This is my data set. Yeah. So what I do is I try to print so this is called a histogram. Okay. If you remember what's a histogram, this is a histogram. So if you remember, there was a feature called households, and this is the histogram of my feature households. Uh, all right. Okay. So this is the histogram of my house median age. Uh, Okay, this is the histogram of my median house value. Okay, so what does this histogram mean? Let me tell you. Um, these x-axis, the numbers, these are not properly visible here, but sorry, these are not properly visible here, but they are numbers like, they are numbers of which look something like this, 10, 20, 30, 40, 50, 60. Okay. So each bin represents how many, so each bin, so if I just zoom in here, let me check if I can zoom. Yeah, just zoom in and tell you what something. Okay. Sorry for the. So if you simply look at one small bin, what it means is, say I'm talking about this bin, okay, the small bin. All right. So the width of this bin is a range of numbers. Okay. Uh, a range of numbers. Maybe it corresponds to some, let's say, a couple of houses. Okay. If I index my houses, this width represents some range, and say this index of these houses are in this range. We are talking about the houses in this range. That's my width, and the length represents how many of them, how many houses are there of in that particular range. Okay, this is what it means. So if this number where, if this range were say 30 to 40, that means around 500. So this number corresponds to around 500, right? So 500, so there are 500 houses in the range of 30 to 40, something like that. Right. Same goes for others. These numbers are across different, I guess. Or these are not average. I think these are across different. Yeah. So the numbers are large. The total bedrooms are large because it's not talking about one house. It's rather talking about uh, um, couple of houses in a small area. I guess I'll show it to you why that is the case. Okay. Because this is a histogram for all my features. So this is how it looks like. Okay. So if you see this longitude thing, that means most of the houses are located in this particular longitude. And then most of the houses are located in this particular longitude. Okay. Something like that. All right. Okay. So this is the first step of any ML pipeline. The reason this is our first step is because uh we need to have a look at the data visually. Okay, it's very important. This is called data visualization. So make sure that you visualize the data in terms of, this need not be the case. You can visualize in some other ways as well, but you have to visualize the data in terms of uh, some statistics, some graphs. Okay? And if you do that, you will find a couple of things. You will find that this data set has some missing values. Uh, you'll also see that the feature called ocean proximity is a categorical feature. So when I mean say categorical feature, it means that it's not continuous. It is a category. So it seems like yes, if the value of ocean proximity is yes, that means the house is in the ocean proximity. If it's a no, that means it's no. It's not a number. It's a it's a category. So I can provide a statistical summary of the numerical appreciates. Then we plot the histograms to visualize the distribution of each numerical feature. That's what we did so far. Okay, let's move on. So what do we find from these histograms? You'll see that cape data. So, okay, so let me tell you what this cape data is. So if you see, there is a one long bar out here. There is also one long bar out here. Okay. The reason this is pretty long, this bar is too long, is because the organization who tried to, for example, collect this data kept all the information beyond 50 into one bar. So, for example, if a particular house has an age of 55, then it has been put in the category of 50 to 51 or something. Anything beyond 50 has been put in this category. So that's why it's called cape. So same thing goes for here as well. Median house value. If the median house value is more than this particular number out here, then it has been kept out here. So this is something you can see. So that's why. So you see, you can see a lot of information in this visualization. That's why it's very important to visualize the data first. Okay, so scaled income. So yeah, so if you look at the scale income thing, what happens? Where is the scale income? Yeah, so if you see there is a small bar out here. So this is also been kept at 15. Okay. This has also been kept at 15. Okay. Kept at 15. Right. Varying scales. So informations are in varying scales. That is also important. Why is that so? Okay. Yeah, that is true. Uh, yeah, but is it visualized? Is it here in the diagram? I don't think it's. Yeah, again, it could be the case that this total number of rooms are 6,000, should have been six, but it's scaled to 1,000 or something like that. That could be an issue. That could be something. No worries. We can find all these informations from the histograms. I'll provide the slides. Don't worry. Okay. We create a test set. So as I said, there can be different issues that can happen when we create a test set. Okay. Uh, you must create and set aside a test before any deep data exploration. This prevents data snooping bias, where you might unconsciously select a model based on patterns you see in the test set, leading to an overly optimistic performance evaluation. It's like an exam. Okay. If you are appearing for an exam, you can think of the exam as the test. That's why it's called post probability test. Okay. Now, if I tell you the questions in the exam that will appear in the exam, then you will learn nothing about that particular subject because you know the test questions. You will study nothing. Okay? But if I do not tell you anything about the test questions, you will most probably study for the test and you will learn a lot of things about the subject. Okay. So it's important that the test set is kept completely aside before any sort of data analysis. Okay. Do not touch the test set at all. Keep the test set aside. Keep it uh, keep it aside. Just give me a minute. I'm getting a phone call. I'll just most probably just decline the phone call. Just give me 10 seconds. Okay, sorry, I'm back. Um, so this is your test set. And keep the test set away before any sort of data analysis. You wouldn't want the test set to be you wouldn't want the model to know about the test set. It's a test. Let the model test on it. Okay. So one of the good practices is called stratified sampling. What is a stratified sampling? Let me explain to you what such stratified sampling is. Um, the word stratified sampling comes from the word strata. Okay, strata means what do you say? It's some sort of a division. Okay. Uh, you divide the data into different strata. That means you divide the data into different types of. So if the data were, if the data had people, if you were working with a data which is on people, then you'd rather divide the people as male and female. And why would you do that? Because when you make your training set, you wouldn't have all the samples in your training set as male people. Okay. If you keep all the males in the training set, then most probably the model will not be able to perform well on the test if the test is a girl. Okay. So we need to make sure that you have enough of samples from different groups of data or different strata. You have samples which are both males and females. Okay. And so that if in the test a female appears, then you would be able to, if the model will be able to understand what's going on. Okay. So that's when we do some sort of a stratified sampling. Okay, what's written here? Stratified sampling is used to ensure the test is represent. Exactly. It should be representative the world. Okay. Okay. This creates we will create a test set where a distribution of income categories matches a distribution in the full data set, avoiding sampling bias. So when we create the test set, we will make sure that that this particular set, when you create a training set or when we create a test set, we'll make sure that this particular set has the same distribution of incomes of the incomes of the families in the households as in the entire set. Okay. Why would you do that? Because you wouldn't want to keep only highly earning people on your training set and only low income people on the test set. Okay, you wouldn't want that because if that were the case, then the model wouldn't perform very well. Right? You would want to have a uniformity. You would want to have a homogeneity in the thing. Okay. So this is all about stratified sampling. Yes, this is the thing I wanted to talk to you about. I'll just zoom in a bit here. So you see, this is what the data set actually looks like. So this thing you see out here, this entire region, this is the entire state of California. It's towards the coast. And the small dots are your data points. And these dots does not represent a house. Rather, this represents a very small region. Okay. So this is a very small region. Yeah, this is a very small region. This one out here is a very small region. These are small regions. Some are very large regions. This is a very large region. Okay, so these small dots represent different regions. And what does the color represent? So the color represents the median cost of the houses in that region. Okay. Yeah, if you see, you'll find that the houses near the coastline are very expensive. Okay, and that makes sense because if you'd like to have a house facing the ocean, you'd have to if you have to spend a couple of bucks, a couple of dollars, $1,000. Okay, that's why it's very expensive. So it can go as much as these yellow ones out here, which is like a $500,000, which is like $500,000 average. That's like the median we're talking about. We're not even talking about the max. The max will be in some millions. It's California after all. But yeah, the median is very expensive towards the coast. So this is again a different sort of a data visualization you need to do to see everything is fine or not. Okay. Again, I don't know where Los Angeles is. Should be around here somewhere. Should be around here somewhere. I'm not sure, but yeah, Los Angeles might be a bit expensive. So that's why you might see a little bit of a color change out here. Los Angeles is like the Hollywood, Los Angeles, all those things. Okay, if you know what those are. Oh wait, this is Los Angeles. Yeah, if you see, then yeah, Los Angeles is quite expensive. Not sorry, my bad. This is not Los Angeles. Anyways, yeah. So this data point. So if I click on this one data point, you will have this particular table. That means the size of the average size is 143 something, latitude, longitude. Median house value is $56,000 here. The median age is 19 years. Population in this small region is 1,430, something like that. Okay. Now, what are we trying to do? So we are going to train a model on this data set that we have. And if we were to um, build a model on this data set, we'd like to see the cost, the average, the median house cost of this data of a test set. That's what the model is trying to do. Okay. Uh, some questions, sir, from where we can reach out this type data sets of our research and projects. Okay, good question. We will do this. I will show you from where you can get these data sets, but you can find these data sets in Kaggle as well. So there is this platform. So Kaggle is a place where you can actually find lots of data sets. There is one more place you can find data sets. It's called Hugging Face. But yeah, Hugging Face is also a place where you can find data sets. You can also directly import these data sets in Collab Notebook, which we will do today. So no worries. So let me quickly finish it off. Okay, so this is an interesting plot. So this plot is, okay, so how best to explain this? There's this thing called correlation. These are all mathematical things. Correlation, yeah, these things are, all these things are pure statistics things. So I wouldn't explain too much on the statistics, the math, because it's a different part of the story. I'm focusing a bit more on intuition here. But yeah, someday maybe I would like to visit your university or be a visiting professor or visiting student or whatever and teach you all the mathematics if 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 that is a possibility. But let's not do that now. The correlation means something like there are some questions. So can you write that second one name? Okay, the second name is called Hugging Face. Huggn Hugging Face. Yeah, you can find it here. It's called Hugging Face. You can find this in Hugging Face as well. Yeah, no worries. So this is called a correlation table, but not exactly a table. This is in the form of a visualization. All right. When I say visualization, I mean something like okay, so this is a bit going to be a bit difficult for me to explain without mathematics, but let me try. Um, okay, it's pretty simple. So let's have a look at this graph. Okay, so these points that you see out here are these individual points out here. Okay, so here you can see that the points are some points are large, small, some points are small. The region, some points are large and some are small, is because these points represent some sort of size of the area. Okay. So if you remove that particular notion of size of that particular area, and you would simply want to represent that point as a point, or that point as a as one some random area, then you would have points of the same size. Okay. So all these points represent points in the same this California data set we are talking about. And what are we plotting here? Okay, we are plotting these areas against two things. This x-axis is the median income. So the x-axis is the median income for all these four plots. Okay, and the y-axis is median house value across these four plots. So the y-axis here is median house value, and the x-axis here is the median income. So we are plotting these households against median income and median house value. I'm plotting them. All right. And if I plot, you'll see it looks something like this. So if you see that there is an upward trend here, there's very small upward trend. It is not very significant, but there is a small upward trend. That means as I increase in median income, my median house value increases. And that completely makes sense. If you are rich, you are going to buy a bungalow, most probably towards the coastal side, if you are super rich. If you're poor, you are not going to buy a super uh, high valued house or bungalow or apartment or whatever you say. Okay? So somehow this plot represents the information that if I'm rich, I'm going to buy an expensive house. If I'm poor, I'm not going to buy an expensive house. That's the meaning of this upward trend here. As median income increases, my median house value also increases. Okay. Similarly, you can see something here, which is like the opposite. The x-axis here is the median house value, this one, and this is my median income. Okay. So as my median house value increases, that means my income also increases. Yeah. Mm, So these two graphs are important. These two graphs are interesting, but there are some graphs which are not very interesting and not very informative. So, for example, this graph. This is a pure. Um, I don't know how best to describe this. This is a pure rubbish plot. There is nothing out here. Okay, doesn't represent that anything. And why does it not represent anything? Because look at it. What's the x-axis? The x-axis is housing median age. What's the y-axis? The y-axis is median house value. Why would the house value be a bit dependent on the age, right? But yeah, sometimes it does depend on age, but apparently in this data set, it doesn't seem like it depends on the age. It doesn't seem like, hey, if the house is very old, um, was built like in the during the 1600th century, it's very costly. That's why it's very costly. I mean, I don't see something like that here. Similarly, goes for this some sort of a data set, which is like the opposite of this one, and this is also something like that. The total number of rooms and median income. No relation. No relation. And why would there be a relation? Uh, okay. So far, so good. Any questions? What if I want real data instead of historical one? Real-time data instead of historical one. Yeah, you can work with real-time data. You would rather you would most probably have to work with an online platform, as in this online thing I talked about. Real time, as in data is flowing, right? That's what you mean. I think. Yeah, you can do that. The the model will change. Using APIs you can fetch real time data. Yeah, you can do that. You can use APIs to save. Yeah, you can call APIs and say bring about if any one of you are into finance, then you can talk about stock prices and stuff. You can do that. Yeah. Um, we can also directly call from external websites. You can always do that. Yeah, you can call real-time data and work with it. Yeah, so this is what the correlation plot is. I explained to you this does not require, I did not require this slide anymore. Yeah, so yeah. Okay, so there's one more thing. We can actually um, create new features. Okay, how do we create these new features? See, in our data set, we did not have any feature called rooms per household. Okay, we can actually create that feature out here. How would you do that? Just divide the total number of rooms with total number of households. If you divide this column with this column, you'll get rooms per household in my data set. Okay, you can create some you can create some data set. So this is called feature engineering. You can engineer some new features. You can also create bedrooms per room and stuff. These are important. These feature engineering things are also important. We can do that. Yeah, right. Okay, there is one more issue we need to handle. It's called handling missing values. So this is a very interesting thing. See, you would want to use all the information you have on your hand. You wouldn't want to um throw away data. You wouldn't want to do that. Why would you not want to do that? The reason is it's information. It's information. Every bit of information is important. Okay. You, if you are a CBI agent, you're trying to solve a murder and a murder case or a homicide case, then you would want all the informations that you have. You wouldn't want to throw away any piece of information, even that information is rubbish. So if you want to solve this problem, this puzzle, you would this puzzle of making the model work, you wouldn't want to throw away any information. You would always want to keep information, whatever information it is. So in that way, you also want to keep missing values, the rows with missing values. Why? Because one of the values are missing. What about the rest? We still want rest of the information, right? We still can use the rest of the information which is not missing. So how do you tackle this missing value problem? So one thing that you can do is replace that missing value with the mean of the entire column. So it's called a scikit-learn, this package in Python. It's called a uh, imputer. So there are these mean imputers, median imputers. So mean imputers is something, imputer you set it equals to mean. Simple imputer you set it to mean. It means that you are filling that particular missing value with the mean of the entire column. You can also fill it with the median. Okay. You can also fill it with the mode. Mode is you fill that missing value with the value you have seen highest number of times. That is a mode sort of a imputer. Okay. So handling categorical data. So this is again one more problem that we need to tackle. And why do we need to do that? Because see, all these numbers you see here. Sorry, where is my table? Yeah, all these numbers you see here, all of these are numbers, right? All of these are numbers. That means they are continuous values. Longitude is a number, latitude is a number, housing median age, total rooms, population, homes, median income. These are all numbers. That means my model knows how to handle numbers best. Okay. My model knows how to handle numbers, right? But what do you do with categories? The categories are classes, right? When I say categories, I'm talking about this particular thing, ocean proximity. The value of the ocean proximity of a house is yes or no. Okay, right? You cannot deal with yes, the word or letter yes, or the word and letter no. Okay, you will have to change this yes to a number, no to a number. Okay, some sort of a representation in numbers for the model to work out. How do you do that? That is called uh, handling categorical data. Okay, we need to handle categorical data. So one way we can handle this categorical data collection proximity is called one-hot encoding. Okay. When I say one-hot encoding, that means it's if okay, so if I have a house which is close to the ocean, that means the one hot encoded value of that particular house is going to be 1, 0. That means one for the fact that it's clear it's towards the ocean proximity, 0 for the fact that it's not. Okay. And if the house is not near the ocean, it's not in the coastal area, then I'm gonna encode it as 0, 1. Okay. Something like that. It's like a binary column for each category. And one for whether it is correct for that category, 0 for whether it's not. One last thing that we need to talk about is feature scaling. Why do we need to scale the features? The reason we need to scale the features is because the data is in different standards, varying scales. Okay, so it's going to be difficult. Say, for example, it's like, yeah, different scales. So you find it very difficult to, similar to the idea that you find it very difficult to deal with dollars, right? You will find it very difficult to deal with dollars. Why? Because you are more familiar with the Indian rupee, right? So what do? You change the dollars to Indian rupee and then you do all sorts of reasoning. So if I pick one of you, I'll just say that, hey, I'm gonna give you $10. You wouldn't recognize the fact that I'm giving you $10 as $10. What you will do is you'll first convert this $10 to say 850 rupee, Indian rupee, INR rupee, Indian rupee. then you say, oh, okay, so you're giving me 800 rupee. Okay, fine. That's it. So you're going to, you would want to represent the data in the same scale. If you do not represent the data in the same scale, then it's going to be difficult for the model to provide you with um, the correct information. So that's what we call as feature scaling. We scale the features. There are different ways of scaling features. One is called min max scalar and the other is called standard scalar. I will not explain what these are. These are some, what you do is you subtract them, you subtract the number from the max and you divide with the difference. Okay. In standard scalar, you subtract it from the mean and you divide it with the standard deviation of that particular column. The reason you do that is so that the mean of the data is set to 0 and the variance is 1. Okay. Right. Any questions? Okay. So you guys are discussing. That's fine. Great to see that. All right. Yes. Now we'll talk about two different models. One is the linear regression. So these are two different models to tackle regression. All right. Now don't ask me how these models work. This is the next thing we will see, how these models work. We will come to this next. Uh, next as in um, linear regression decision. Okay. So this is a, so if you fit this linear regression to our data set, don't worry about how linear regression works. Don't worry about how to fit linear regression. I will show you that. Don't worry about why we are fitting linear regression, why we are fitting decision tree regressions, why not any other regression things. Don't worry about that. Just for a time being, assume the fact that these are two different regression-based machine learning models. I will explain how these models work. Don't worry. I just want you to have a look at the data, the output. So if you remember, RMSE was the root mean squared error. Okay, so if you fit a linear regression, the model has a root mean squared error of around 68.628. This number is very high. Yeah. Why is that high? Why is that high? Okay, so if I standardize, it's going to change the numbers. Okay, don't worry about that. So this now, yeah, don't worry about why this is high, but just know that this is high. And because this is high, that means my model is underfitting because my root mean square error is high. That means I am too off uh, the true mark. Okay, so it's kind of underfitting it. What is underfitting? That means my model is too simple. So linear regression is too simple to capture the data's complexity. Can we fit a decision tree regressor? So don't ask me what's a decision tree. I will explain in due time. For a time being, just assume that this is a machine learning algorithm. It's called a regression based algorithm. I fit decision tree. I get a RMSE of 0. That's strange, right? RMSE of 0 means the average error is 0. That means there is no error at all on my training set. And that's impossible, right? There has to be some error because everything has error. RMSE of 0 is not true. That means it's overfitting. My average error is 0 in my training set. That means I'm um I'm overfitting it. That's what it means. I'm overfitting. Okay. That means my model has memorized the training data, and that means it will not generalize. Okay. It's like you're praying for the social studies examination. Instead of understanding what's happened with the Mughal dynasty, instead of understanding what's with the British Empire thing that's happening on the country and all those stuff, you kind of memorize the entire textbook and you do not understand whatsoever is happening with history in history. That's overfitting. Okay. If I give you a question which is outside the book, you'll not be able to reason properly. Okay. So you will not be able to do pretty well outside the premises. It's overfitting. You're overfitting. Okay. Underfitting, on the other hand, is you have the textbook, you did not study for the exam. It's underfitting. Okay. Okay. So far, so good. I have talked about k-fold cross-validation. I will not talk about it. I talked about 10-fold cross-validation. That means we divided data into 10 different parts. We train the data on the first 9, we test it on the 10th. Okay. And we do this for the different, for each of the different 10 parts we have. Okay. So if I do this on this data, you'll see that the decision tree cross-validation results. So CV means cross-validation. The average cross-validation score was worse than linear regression, confirming that it was overfit. Okay. Random forest regressor. Again, this random forest regressor is a decision tree based regressor. So it's yeah, don't worry about what's on ensemble model. I'll talk about that if time permits. That trains many decision trees. So it trains many decision trees, and the output is that it performed much better. 52. It reduced from 68, my RMSE from 68, which is very high, to 52.56, which is not very high compared to the problem we are solving. So this is a any questions? Okay, you want a break, right? Sure. Let me finish this and we can take a break. I don't have much time. So this is k-fold cross-validation. This is cross-validation results. So there are two different kinds of hyperparameter tuning. Yeah, so don't worry, I'll give you a break. We can take a break. We can take a lot of break. I just want to finish this because I think we started a bit late, right? Because there was some internet issue. And just for your sake, I would like to finish everything before 7 because I do not want to trouble all of you with so much of work and studies. We all are, it's a weekend, right? I'm already glad you all are here listening to my boring talks. So I'll try to finish it off before 7. Uh, Hyperparameter tuning. When I say hyperparameter tuning, there are two different kinds of hyper. So if you remember what's a hyperparameter, it's kind of the the model parameters, the values you choose, right? Something like that. Some sort of the values that you choose for the model. Okay? So don't worry what the hyperparameters are for this linear regression model or decision tree. There are a couple of them. So there is a so we need to so so these are hyperparameters, right? We need to find the best value, right? So to find the best value, there's some techniques. Okay, one is called grid search. Don't worry what's a grid search. Don't worry what's the random search. I have not written random search. So these are some techniques which you have to study. I just want you to know the names. That's why I put it up here. I can still define grid search for you all if you want. So these are some techniques: grid search, randomized search, randomized search. So these are two different techniques of hyperparameter tuning. So hyperparameter tuning, that means we are trying to find the best set of hyperparameters for the data that we have. Okay. So it's like asking a question, what are the best hyperparameters that we can find for this model? Okay. Uh, right. So if you do the hyperparameter tuning, you'll see that this number further reduces from 52 to 49. Okay. So this is kind of a pipeline. Okay, we follow. We tune the hyperparameters. It's important. You have to do all the time. This is something you have to do all the time. Okay. Then there's some feature importance, which I will skip. The reason I'll skip is because this is a part of this model called random forest model. So this random forest model outputs some sort of feature importance. So if you run this model, you will be able to see, you will be ranked the most important features. Which feature contributes most to my median um, what was it called? Median, yeah, median house value. Right, sorry. I guess it's median house value. Yeah, the median housing price. So it means that, yeah, it means that, right. So it means that the most important feature is the median income. That is something you can, I'll show you to how that happens. The second most income is like this thing calling land. Let's not worry about it. So yeah, it's pretty interesting that these kind of models give you the importance of the features. Okay. All right. So okay, we have set the model. We have done all sorts of things to my training data. I put a model. I try to tune my hyperparameters. I try to do k-fold cross validation. I try to fit different models and see which performs best. I try to handle missing values. I try to handle categorical values. I did some feature scaling. I did some feature engineering. Okay, I did a lots of things. I did some correlation analysis. I did a lot of things, and I have a model with. I have a model with me now. Don't worry what this model is. I have a model with me now, and it's nothing but the model that I choose is the tune random forest model. Don't worry what this model is again, but it seems like this tune random forest model performs best in my training data. Yep. After doing lots of stuff. Yeah, so this is my model. Now I will test this model. It's like the final examination. Okay, I'll see how does that model perform in my test. Okay. So yeah, okay. So this should be a decimal here. This is a typo, 47.766. Okay, that's not 47,766. So this is my final performance. Okay, this is your test score. You appear for a test, how much you score. Okay, so training is like the pre-boards, final performance is like the boards. Okay, so you see, you perform pretty well. You perform 47.766, which is pretty good. The training was 49. In fact, you perform better in your boards than your pre-boards. That's quite interesting. Okay. This doesn't happen quite frequently. I've had a lot of experience doing this. It's quite range, quite rare. All right. This is okay. Now we launch it. We launched this model to the production environment, and we connect it. We put this. We give it to the investment practitioners in investment and stuff, and say, hey, this is my model. You can use this model. Okay. We need to keep monitoring the model, because if we do not monitor the model, what happens is called model rot, because models can degrade over time. Now, this is not a physical thing. It's I mean, this doesn't. I don't think this holds for batch line or batch models kind of stuff. But this usually holds in online settings. Uh, okay. Then we maintain it. We maintain the model. We Yeah. Great. Thank you. This is all I have for the slides. I am exactly on time, which is 6:30. I'll probably take a couple of questions. And okay, okay, you're not finding it boring? Glad. Thank you, thank you. You're not finding it boring. Thank you so much. I am glad you liked it. Okay, can you please answer this? Yes, definitely. I'll answer you. So with RMSE, we know if our model is overfitting or underfitting. Uh, Please explain standardization again. Okay, I will do that. 1 second. With RMSE, we know if our model is overfitting or underfitting. Yes, but not exactly. There's a mm, so RMSE, we can actually, yeah, we can find that the model is overfitting or underfitting by looking at the RMSE. but it doesn't give you a quantitative information about how much is it overfitting or how much is it underfitting. Okay. So there is a different metric called R squared or adjusted R squared. I'll just write it in the chats. Okay. It's called R squared. I did not put it here because, these are lot of information. Uh, you wouldn't want to remember all of this, but just because you have asked me this question, I'll say. So these are two different techniques called R squared and adjusted R squared. Okay. So these will not only tell you whether it's overfitting or underfitting, these also give you a quantitative measure of how much it's overfitting and how much it's underfitting. All right. Okay. What's the next question? I hope I have answered your question. Okay. Yes. To answer your question, it does. It does. You can actually uh you can actually find out whether it's overfitting or how exactly we know under or overfitting. Okay, got it. Okay, fine. Okay, you got it. If the number is too high, it's if the RMSE is too high, that means you are using a simple model. That means the errors are too high. That means you're underfitting. Okay. If the RMSE is too small, that means the errors are too less. That means you are overfitting. I hope I have answered your question. Please explain standardization again. So let me explain standardization once again. Uh, okay. See, I give an example, right? When I said, yeah, no worries, no worries. I'm glad I could answer your question. Uh, Advait Patel, thank you. And okay, what was I doing again? Right, standardization, exactly. Um, okay, so this is going to be a bit. So standardization, the concept of standardization comes from a little bit from statistics. It has a statistics flavor. Has a flavor distributions. But let me try to explain best. So standardization is a normal. It's a technique. It's a normalization technique. It's not exactly this normalization. It's just a normalization technique which people use so that the columns, if you standardize a column, so you always standardize a column. Okay? The features are your columns. So if you standardize your columns, that means you are changing the mean from the original mean to 0. And the variance of that column is changed to 1. That's what it does. It's just, it's like you can think of this as like you have some plots out here. Okay, you have some plots out here. You bring okay, so you have this say you have this plot out here. Okay, you have this plot out here. So what standardization does is it shifts this plot from this particular position to the center so that your mean is 0. And it kind of collapses the data points together so that the variance of the data points are 1. Okay. So this is a normalization technique. Don't worry much about why people do this. It seems like there is a massive advantage of doing that. For example, if standardization it's a must in PCA. It's a dimensional reduction technique. It's called principal component analysis, which we will see later if time permits. But that's what standardization is in short. All right. Any more questions? Yes, I'm going to implement it now. Actually, I have already implemented it. I'll just run the entire code in front of you because if I start writing the codes one by one, then it's going to be too boring. But before I do this, I don't have much time. I'll try to finish it before 7:75. Uh, okay. And I would like to give you a 5 minutes break. I would have given you 15 minutes break, but uh, We are lagging behind a bit on time, so I'll give you a 5 minutes break. I hope you all don't mind. Okay, let's take a break of 5 minutes. In the meantime, I'll set up the Python thing. Okay, thank you. Let me know if you have any questions. Ram Ram. Thank you. Yes.
Hello, sir. Shall we end the meeting?
Sorry.
Tell the
Are you?
participant to switch on their camera.
Uh,
So I was asking that if you are completed, so we can end the meeting.
I think I'm not completed. I have yet to do the Python thing. So can you just wait for like 20 minutes?
Yeah, sure. Yes, sir. Sure.
Yeah.
It's just key when you are completed, like then before 2 to 3 minutes, we will take a screenshot of the meeting so that we have to show it to our heads.
Definitely. Yes, definitely, definitely, definitely. I will do that. No worries. I'll do that. So we are just taking a few minutes of break.
Okay.
Uh, yeah.
Okay, sir.
Okay, so welcome back. Let me tell you a few things. I have uploaded the presentation files as well as so you guys can hear me, right? Okay, you want to see me? Yeah, definitely. So I mean, we can definitely go live someday. Let's finish it. Let's finish it off quick. Um, right. Ram, sure. Yeah, okay, sure. So if you guys all can hear me, this is the link to the GitHub. If you do not have GitHub, then you can just log into GitHub using a Google account. It's a standard practice. If you do any projects, you just have to upload the entire files and documentations, your revision history and everything will be there in GitHub. And yeah, GitHub is like the standard place where you deploy something, and where push it. When I say push it, as in you put up your project documents, your project codes, especially on this particular platform. So if you click on this link, you will be redirected to um you will be redirected to the GLA workshop page, and you will see my presentation slides out there on day one. So there is one extra slide out there. Don't worry much about that. And there are the Python codes as well. Okay. And this is my GitHub profile. You all can you all can follow me here, and yeah, you can see my work here as well. It's pretty basic for now. And if you click on, so you can actually download the Python notebook, which is available here. So you can also start it. So there is a star option out there. So you can see a star option out there. So if you start that repository, we call it a repository. If you start a repository, this repository will appear on your what do you call it? Uh, I don't know, where does it appear? On the stars. Okay, so you do not lose this repository. Okay, you can do that if you want. Yes, someone has a question, or am I? Okay, no one has a question, or someone has a question. Okay, no one has a question. Fine. Oh, sorry. My screen is not visible. Okay, sorry. I did not know that. I'm really sorry. Let me share my screen. Ah, where is my? Yeah, this is the thing I'm sharing. Sorry about that. So this is the repository. This is the workshop I'm talking about. And so if you go to my GitHub, okay, my net is a bit slow today. Okay, I don't know what's wrong. Okay, so this is my GitHub. You can follow me here, and you click on repositories. If you click on the repositories, you will see this workshop GLA. If you click on this workshop, you will get the slides, which is on day one. If you just start it out there, if you start it here, then you will be able to see these. I don't know where. You will be able to see it somewhere. Yeah, you will be able to see it over here. These stars out here. Okay, on your repository. And on if you click on day one, you will have two documents, two folders. One is the slide notes. I have put up all the slides out here. All right. And I have put out the notebooks out here. Okay. So the notebook that I would like you all to run is this. This is the notebook. So if you click on this notebook, there is a download option here. Okay. If you just download it here. Okay. If you click on download, it will get downloaded out here. Okay, it gets downloaded out here. Okay. Now what you can do is go to go to this call, go to this. Okay. Okay. So go to this new account, this new Google Chrome, and just click Google Colab. Okay. You will get this site. It's called a Colab, which is where you can do all sorts of Python coding and stuff. Click on Welcome to Colab. Okay. You can also go back and click on a Colab notebook. It's your choice. So if you go to Colab notebook, you can go to File and you can click Upload notebook. Sorry. Go and you'll see an upload notebook out here. Then what you do is just drag it out here. I don't know it. The dragging doesn't work here. Okay, I think the dragging doesn't work here. It should work, right? Drag the file in. I don't know why it's not working. Uh, okay, I think I have to drag it from here. Okay. So just browse it. I'll just browse it. I will browse it from. Wait, in which format is it then? Okay, it's in IPYMNB. It's fine. Should be fine. Uh, check D drive. It's not here. D drive. Okay, it's here. This one. Okay. Just upload it here. Okay. So if you upload it here, you will get this dataset. Okay. Uh, Change the name if you want. What you do is once you upload this notebook, just click on runtime and just click on run all. You don't have to click on this. You can simply delete all this because I have borrowed from a. Okay. So if I don't think we have time to go through the entire notebook. We can continue with this notebook from tomorrow as well. But let me go through this a little bit until 7:05. So yeah, so I'm doing this entire project here. I'm going to okay. So there are different versions of Python. Okay. So this notebook is works on Python 3.5. I think the most recent Python version is 3.1, 3.14 or something. But this works with more than 3.5. Okay. So this is the place where you import all the libraries. Now, don't worry, it might seem a very bit scary. All these things might seem a bit scary. What is this version and all this, but they are pretty computer science things. If you know what is OS, it's the operating system thing. So with this library OS, you can actually work with your computer operating system. Okay. So sklearn is the most important library out here. So please remember this word sklearn. Uh, if Even if you forget everything else, don't forget the word sklearn. Okay. It's called scikit-learn or sklearn. And yeah, so this is the library that does all most of the ML stuff. This matplotlib is mostly for mm, you know uh, the visualization purposes. Okay, these are your libraries. Now we get the data. First of all, we download the data. How do you download the data? This is how you download the data. So you call the important libraries. You look at the root, the exact root, the website where you can find the data. Then you connect your operating system with that particular website and you join with the datasets. Then you collect the URL and you define a function that uh, kind of calls this particular website and then downloads the data for you. Okay. So if you call fetch housing data, this will download the data for you. Okay. So PD is a very important library. It's called Pandas. The name is a bit funny, but that's fine. It's called Pandas. It's so this library is mostly used for what we call it. Uh, there's a specific word for that. I'm lacking the vocabulary. What do you call it? Uh, so basically, you data manipulation. Exactly. Thank you. Thank you. Thank you. Yeah, that's what I was looking for. For some reason, the word manipulation was not coming to my mind. Okay. Just give me a minute, all right? I think I have a important document. Sorry about this. Uh, okay. So um, we call this housing data, which this is how this housing data looks like. You see, this makes much sense. Okay. As I told you, each of these individual rows should remind you. Sorry, each of these individual rows should remind you of one particular um, area. Okay, so again, if you see ocean proximity, it's not a number, it's a category. The category is near bay. That means near the Bay Area. Okay, so don't worry much about what's a Bay Area, but it's some sort of a category. With this advent of GenAI, you also have the you can also have a look at these generated codes in Colab stuff. All right, and okay. So just forget about this, forget about all this. Now I can have a look. So these are some stuff we do. Let's look at the main thing. So this is the describe the table, if you remember, table I was talking about, the summary table. If you remember that I was talking about, this is the summary table. One second. All right. Um, yeah, so these are the plots that I was talking about, the plots that I showed you. So these plots, these plots. Okay. These are not in a good, doesn't look good now, but it looks good here. These are your plots. And double click here for zoom purposes. These are your plots. I've already explained or described to you what these plots mean. So I'm just showing it to you in code here. So the matplotlib library is used to code it. Okay. All right. So we are creating a test set here. So this is an important command. This is called random seed. And I will not explain what a random seed is. You should go and have a look at in the internet what a random seed is. It's an interesting thing. So I'll split the data set into train and test. This is how you do it. I'll not go through the code, uh, but the code is not very difficult to understand. Don't worry if you do not know Python, you can still work with it. And yeah, we can still work. We can still work with it. Python is a language which is very much interpretable. Yeah. So I can explain you the code, but the notebook is already long enough to. So my train set has 16,000 house areas. My test set has 41,028. And if you see this point two, this is like the train test split thing. So point two means point two is the point two of the entire data set is my train set. And one minus point two, which is point eight. Point eight of the entire data set is my training set. Okay, so I'll go through this in detail, but I just wanted to show you something else. Yeah, so these are some individual plots and stuff. Yeah, so this is the visualization in one way. This is another sort of a visualization which I've not covered in my on my on my you know slides, but yeah. And this is the one I was talking about, the one here. If you remember, I don't know where it is. Yeah, this one I was talking about. Yeah, this is this one. Sorry, where am I? Wait, yeah, it is this one. You will not be able to click it here though, but yeah, you can actually code it out to click it. Okay, so so this is the image. Can find the image here. No worries. So yeah, this is the image. This is the image. This is the image. So you see these areas are quite red. The one near the coast is very red because you're facing the beach. You are the privileged group of people facing the beach, so you need to pay a lot for that. The correlation thing, if you remember that I was talking about, this that graph we I was looking at, this looks something like this, and this is the diagram I was particularly concerned about. Yeah, this is the one. And if you see some sorts of this horizontal lines out here, which is like the caped thing I was talking about here as well. Okay. So any number beyond this line has been put up in this line, something like that. Okay. And this is one other plot. Oh yeah, so this is like the data cleaning thing. You remove the missing values. Okay, you remove the missing values. You drop uh, you drop. So this is one option where you know so this is one option. One option is you drop the columns where the total bedroom number is missing, for example. Okay, this is one option, but that would lead to you know loss of information. So another option is you drop the entire column. Okay, this is one option. This is one option. And the third option is you replace the missing values with the median. So replacing with the median is the most appropriate thing people do. Another way of doing this is this one. Okay. So you replace the ones. So these total bedrooms that are not available here will get replaced by uh, yeah, this NA nuns, not a number. None means not a number. This will get replaced by some sort of a number. Okay. Then, yeah, so this is called a simple imputer that I was talking about. Okay, so these are some stuff. Don't worry much about it. Uh, all right. Yeah. Okay. Yeah. So this is the place where I. Okay. Anyways, I'm out of time today. We could have finished it if we had started a little bit earlier, but that's all right. We can have a look at this tomorrow again. See you tomorrow, maybe, and we can have a discussion on this. And in the end, we deploy it. I mean, we will have a look at it. In the meantime, you can go through this notebook, and if you have gone through this and everyone's fine with it, I can start off with a new topic, if that sounds all right. And this is the so all right. So this is the the repository I was talking about. I'll share it again here. if anybody has missed it. Wait, what's wrong? Okay, stop sharing. Uh, I'll just share it with you all here. Yeah, so this is the one. You can start it off, and okay. Okay, thank you so much for attending. And is anybody here who would like to take it off from here? Uh, so if you want, so I think I saw someone say that they would like to have a meet with me or something. So since it's not available, not possible today, so I'm just giving you my website. So this is my website. You all can follow my website, and you can find a lot of information about me here. Yeah, so maybe we can have a conversation about all this stuff tomorrow. Yeah, this is all I have. Sorry to have taken 5 more minutes.
So,
And yeah,
so
yeah, hi,
I'll take
hi.
I'll take 2 to 3 minutes of yours also, because I want you to share the slides once again so that I can take the screenshot. And I request everybody to switch on their cameras.
Okay, sure. Yeah.
So can you please share some slides so that I can take the screenshot?
Yeah, sure. Let me share some slide. Yeah. Uh, where is my slide? Okay. 1 second. Don't take the screenshot yet. Let me get to a better slide. Okay. Just give me a minute. Okay. Let's say which slide is something. Which one of yours is your favorite slide, guys? Go on. Which one? This one? This one? This one? Or this one? Let's skip this one. The last page. Okay, you can take a screenshot. Sorry for all that nonsense.
No problem, sir. Yes, sir, it's done.
Okay, thank you. Thank you so much. I hope you all enjoyed.
Thank you very much, sir, for thank you very much, sir, for such a wonderful session. We'll connect with you again tomorrow.
Okay, sure. We can do that. Okay. Right. Is Priyanshu here by any chance? Or should I just call him?
No, sir, he's not there in the meeting, but due to some, like, we also have an event upcoming.
Okay.
So you can contact him like by call or
Okay,
like
sure,
text.
sure. I'll do that. No worries. Anyways, thank you so much. See you guys tomorrow. Bye.
You're welcome, sir.
Bye.
I
Bye.
request
Thank you.
everybody